Now that we've talked about neutral atoms, we've talked about isotopes, and we've talked about ions, we're going to look a little bit more at isotopes in this section. So isotopes, remember, those are the things that have different numbers of neutrons. Remember that, different numbers of neutrons. So that means that they have different masses. If we use this instrument, this is called a mass spec, or a mass spectrometer. Mass specs do more than what I'm about to talk about. They're a very beneficial tool in organic chemistry, but they can be used if you think you've got a sample of something that's pure. As long as it's pure, they'll work for elements. And it shows not only the isotopes of an element, but also the percentage each is found naturally. So if you were to take a sample of magnesium from, I don't know, somewhere, someplace in the Smoky Mountains, and if you were going to go to China, and if you're going to go to all these different places and get samples of pure magnesium, the thing about isotopes is that wherever you get them from, they always come in the same ratios of isotopes. So if you got 100 atoms, which would be really hard to get 100 atoms, but if you got 100 atoms, then 79 of them would be magnesium 24, that's the protons and the neutrons. And then, 10 of them would be magnesium 25, and 11 of them would be magnesium 26. Now, some elements have a lot of natural isotopes, and you get a whole huge range of them. Some only have one natural isotope. So this is what we're talking about, is how they're naturally found on Earth. And you remember that you're going to be finding out that atoms are so small that if you, even a handful of some substance is a ton, and I mean a ton of atoms. And so you do that comparison, you end up with that amount of each type of the isotopes. So when you look at this, it's really easy to visually see that magnesium 24 is the most abundant. So our periodic chart, we already talked about this number right here, and we already said that that's the number of protons, and the official word for this is atomic number. Then we have this other number right here, and this number is very, very important, and you will use it all the time. But magnesium 24, this is the most abundant, and it's going to give us information for how do we get this number. So this isotope, it has a mass, and it's like 24 point something that's really close to 24, like 24.00001796. I totally made that up, but those are like what the numbers are like, AMUs. AMU is the same thing, or very similar. It's a unit we use to measure the masses of atoms, because atoms are so small. When we measure ourselves or chemicals, we usually use grams or kilograms, but they are an order of 10 to the 23rd smaller than all of those things. So we use AMUs. So this is, the unit on that is an AMU. And what this number is it's taking consideration this one's mass, which is like around 24. It's got some decimals with it, but it's right around 24. This one's mass, and this one's mass. But you'll notice if I just straight up average all three of those, I should get 25. And notice this number is 24.3. So it takes in consideration the natural abundance. So it weights this number more because that's like way more abundant. So if I do 78% times 24 plus 10% times 25 plus 11% times 26, that's how I get this number right here. We're going to be doing some calculations to practice that kind of math, but there's some shortcuts. And so on this page, I'm going to be showing you the shortcuts. So if you know something is the most abundant, it's going to tell you that the mass of that element is going to be closest to the most abundant isotope. And we're going to be expecting over on here the mass on the periodic chart to be around 24. And it's around 24. It's a little bit more, and it is important that it's a little bit more than 24. But it would make sense for it to be a little bit more because the other isotopes weigh more than magnesium 24, and they matter some also. Let's practice making it easy, and then we'll actually do the math with it. So silicon has 23 stable isotopes, ranging from silicon 22 to silicon 24. Using the periodic chart, there is one that is the most abundant isotope of silicon. What do you think it is? So remember, this is the number of protons. Again, that's the number of protons, and that is the number of protons. Now, this is the number of protons plus neutrons, and this is protons plus neutrons. So even though there's 23, the most abundant one is going to be the isotope that's closest to this number. Like if we were to round that number, the isotope is going to be the closest to that one. So it should be silicon 28. Let's go back up here and look at it again. So if we're looking at magnesium, remember magnesium 24 was the most abundant, and notice that rounds down to 24. So magnesium 24, that's the most abundant element. Isotope. So on your own, figure out the most abundant isotope, and in this one there's two that are 50-50. Figure out which pairs are the isotopes. Remember, you're going to be using and rounding this number, and you're going to be using and rounding this number.